We're going to start out Chapter 2 by talking about atoms. Atoms are the smallest particles of elements that retain the properties of those elements. If we look at an atom, we see that atoms have three different components that make them up. They have protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Here we have a diagram of an atom. And if we look at the center of the atom, we see that protons and neutrons are located in the center of the atom, and electrons, shown in yellow in this diagram, are found on what we call orbitals, or shells, located around that nucleus. And so as you look at those yellow electrons, imagine them moving and orbiting around the protons and the neutrons that are found in the center of the atom, the area that we call the nucleus. The electrons are not anchored to those two sites, but at any given time they'll be found somewhere around that orbital that we see depicted on the screen. Each atom has an atomic number, and the atomic number of an atom represents the number of protons that are found in the nucleus. So backing up to the previous slide, we see the dark blue circles in the center of the atom represent the protons of the atom. And so the fact that we have two protons in the nucleus of helium means that helium has an atomic number of 2. If we look at our periodic table, as we have here in the second slide, we can see that the atomic number is depicted just above the symbol for the element on the periodic table. So if we start with hydrogen at the upper left-hand corner, we see that hydrogen has an atomic number of 1. That means it has 1 proton in the nucleus. Oxygen has an atomic number of 8. That means it has 8 protons. Carbon, 6, and so forth and so on. Alright, and so most importantly, what we're going to discuss on these first couple pages is something referred to as the shell model of atoms. And so the shell model describes the location of electrons within an atom. Every atom has a certain number of shells that those electrons are found on around the nucleus. And so really what we need to specify here is how many electrons fit on each shell. On the first shell, the one closest to the nucleus, we can fit 2 electrons. These electrons have the least energy, and only 2 electrons will fit on that first shell. Every shell after that will hold up to 8 electrons, and so this is sometimes referred to as the octet rule, because after that first shell, no matter how many shells you have after that, each of those holds up to 8 electrons. So shells, one thing that we're going to see is very important, is that shells are complete when they are filled with electrons. The innermost shell holds 2, and the shells outside that hold 8, and as I said, this represents the octet rule. And so interestingly, what we'll see as we talk about these bonds is that atoms will share electrons or give up electrons in order to fill up their shells with electrons. If they have 1 shell, they want to have a total of 2 electrons on that shell. If they have that second shell, they want to have 8 there. And if they have a shell outside that, they want to have 8 on that as well. But the key to remember is this: the outer shell of electrons has to be full. So all atoms want to fill up that outer shell with electrons. Here we see some various atoms of different elements in the location of electrons on their shells. And so first we see hydrogen located on the left-hand side of our screen here, and indicated by the pointer. And so hydrogen has 1 electron. It has an atomic number of 1, meaning it has 1 electron, and so it wants to get 1 more electron to fill up that outer shell. If we move to the right, we have carbon. Carbon has an atomic number of 6, and it meaning that it has 6 electrons. Actually, the atomic number specifically means the number of protons, as we mentioned previously, but in almost every case the number of protons equals the number of electrons. You have 6 positive charges in the case of carbon in the nucleus, which means you have 6 negative charges floating around the nucleus in the form of those electrons. And so carbon has 6 electrons. 2 of them, 1, 2, are located on the first shell, and 4, 1, 2, 3, 4, are located on that outer shell. And so you can ask yourself the question, how many more electrons does carbon need to fill up that outer shell? And the answer, of course, is 4. And so carbon is likely to form bonds with 4 partners in order to fill up its outer shell of electrons. And that's extremely important in our discussion of biological molecules later in this chapter. And so you can look at these other atoms that are found on this page. Oxygen, for instance, has an atomic number of 8, meaning it has 8 protons in the nucleus and a total of 8 electrons. 2 on the first shell, 6 on the second shell. How many electrons does it need to fill up that outer shell then? And of course the answer is 2. And so that'll also be important very shortly in our discussion. Oxygen wants to form 2 bonds to get 2 additional electrons to fill up that outer shell with electrons. Alright, and so at this point then we're ready to transition to the next lecture, which will be our discussion of bond formation between atoms.